Scholars. Today we're going to talk about factoring. Now, you've likely been factoring a lot in middle school and high school. So, for example, when you were asked to factor the number 50, likely you learned how to do a factor tree, right? Something like this. It's 25 times 2, and that's 5 times 5 times 2. And so we could rewrite this as 5 times 5 times 2, or 5 squared times 2, right? This is an example of prime factorization, right? Which is certainly one example of factoring, where we break up a number, we decompose a number into only a product of prime numbers. And you've probably also seen factoring like when we're factoring expressions, right? So for example, we could say 3x plus 6, and we could factor that as 3 times x plus 2. And later on when we deal with quadratics, right, we could factor x squared minus 9, for example, as x plus 3 times x minus 3. Okay, so these are all examples of factoring, right? Different examples of factoring, but it begs the question, what does it mean? What is the actual definition of factoring? So a lot of students actually have been factoring for quite a while, and they can do all that stuff, but they don't know exactly what it means to factor. So the definition of factoring is to rewrite something, a number or an expression, as a product, right? It's that simple, to rewrite something as a product. And we know product, right? This is, here we're talking about multiplication. So to factor an expression or a number, it's just rewriting it as a product. So let's take a look at what we did here, right? We rewrote the number 50 as multiplication. There's a multiplication, right? We rewrote 3x plus 6 as 3 times x plus 2. Right? We rewrote x squared minus 9, right, as x plus 3 times x plus 3. So there's this multiplication that's in common with all these examples of factoring. Let's take a look at a couple of other examples. Factor the sum 56 plus 32 by finding a common factor. So we know what we could do, right? We could just add 56 and 32 is 88, right? And we could factor that or rewrite that as a product, right? That's what we're doing, as 8 times 11, among other different factorizations, okay? But what we're going to do here is we're going to actually look for a common factor. This is something that each of these numbers have in common. So 56, well, I can write that as 8 times 7, okay, because we know our multiplication table is pretty easy. And 32, well, I can write that as 8 times 4. And we see that each of these two numbers has a common factor of 8. Okay, so this is the common factor. And what I can do, if they each have this common factor, I can pull it out of each term. I can take that 8, and I can pull it out. So let's pull it out and rewrite this as 8 times whatever's left over. Well, I have a 7 left over, plus, I have a plus here, that's a, right? So I have a plus, and 4. Okay, so 8 times 7 plus 4, which, right, is actually nothing more than 8 times 11, which is exactly what we got, right, when we added first and then factored, okay? So this is how we can factor a sum by finding a common factor. We don't use it too often with numbers. However, this idea will show up again certainly when we're factoring algebraic expressions, okay? It's the same idea. So we're just doing it with numbers here to show you that it makes sense. And we can even use an area model to represent this, right? We know 56 is 8 times 7. So here, let's just do it all in red. So I could say, like, maybe I have like a length of 8 here, right? 8 inches and 7 inches, right? So this right here is 56 square inches. And I say if I want to add 32, which we know, we said is 8 times 4, right? So maybe 8 inches by 4 inches. Say how many square inches is it, right? Well, we can just add the 7 and the 4 and create one big rectangle right here that is 8 by 11. And so these sort of weird little manipulations that we do up here with numbers, right, they make sense sort of geometrically as well, using the area model. Let's take a look at one more example. And this is an example of where we can use factoring as a tool, as a mathematical tool, to actually create an argument as part of an argument. And this is something that mathematicians do all the time. When you add 4 consecutive integers together, is the result even or odd? So this is an interesting question, right? One way that we can start approaching a question like this is to try some examples. So here, let's just make a little room over here, and let's see, we add 4 consecutive integers. That means they happen one after another, right? So let's try the first 4 positive ones, right? The easiest example we can get 1 plus 2 plus 3 plus 4. And we add them all up, we get 10, and 10 is even. Okay, so 10 is even, and there are even number 10. So let's try another example. I don't know, how about 7 plus 8 plus 9 plus 10? Okay, so that'll be 7 plus 8 is 15, 10 is 25, plus 9 is 34, and 34, that's also an even number. Interesting. And we could even try a bigger number, 97, 98, 99, 100. We could, do 5,000, 5,001. And you can try those, and you'll find out that all the examples that you try, you're going to end up with an even number. Interesting. Is this an argument right here? So this is evidence. This right here is evidence that it could be true that when you add any 4 consecutive integers together, the result is always even, right? It could be true. It seems as though, from our examples, that it is true. But the only way that you could show it is true by using examples, like that it's always true, is to use all of the possible examples of 4 consecutive integers. And how many possible 4 consecutive integers are there in the world? Well, it's an infinite number. There's an infinite number of numbers, right? This is a process of trying examples would never end. So what we need to do, and what we can do, what factoring allows us to do, is it gives us a tool to create an argument to show that this is the case, this would be the case, it will always be even. So let's take a look at how we could do that. Okay, so 4 consecutive integers. Well, let's say my first integer is x. So here we're going to do this, and this is going to be, I'll call it an argument, and we can also use the word proof, okay? This is sort of like a proof. A lot of students may be scared by that word, but it's really just an argument, right? We want to make some sort of point, right? Okay, so let's say my first number, my first integer, let's call it x. Well, if that's my first one, what's my next one? Well, it was 1, the next one was 2. 7, the next one is 8, right? X, the next one is just x plus 1, right? That's how you get from 1 to 2, from 7 to 8. Okay, so x plus 1, and then what's the next number? Well, 1, 2, 3, right? So in fact, now I'm adding 2 from my original number. 7 plus 2 is 9, so this is going to be x plus 2, and we can see where this is going to go. It's plus x plus 3. So this right here is not just 4 consecutive integers, it's any 4 consecutive integers. This right here represents all possible combinations of 4 consecutive integers, right? If you give me a value of x, these will all turn into numbers. That's fine. But when we keep it sort of algebraically, we just keep it with x, then they can represent any possible combination. Okay, so what do? Let's add these things up. X, 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 x. So this all equals, if I add them all up, 4 x's plus 1 plus 2 plus 3, which is 6. 4x plus 6. Okay. Can we factor this? Yeah, right? Because 4x is nothing more than 2 times 2x, and 6 is nothing more than 2 times 3. So since they have the common factor of 2, right, I can pull that out just like we did earlier, and I'm left over with 2x plus 3. So they had a common factor of 2, I pulled it out. So the sum of any 4 consecutive integers can be written as 2 times 2x plus 3. Okay, what makes an even number even? Well, even numbers all have a factor of 2. That's what makes even numbers even. 10 is even because I can write it as 2 times 5. 34 is even because I can write it as 2 times 17, right? And that's what makes even numbers even. And this thing, I can write it as 2 times whatever, 2x plus 3. 2x plus 3, it doesn't really matter what this thing is, right? It matters there's a factor of 2. So this right here in 1, 2, basically 3 lines is an argument that shows all possible examples, an infinite number of examples. No matter what 4 integers you add together, the result is always going to be even. Pretty impressive. Factoring is a powerful tool. Have a great week.